morning students. Welcome to the Digital Electronics video lecture class. So in previous class, we have already discussed about the different types of digital logic IC. So today we are going to discuss about the characteristics of digital IC. So various logic families possess different characteristics. So one family may be best suited to one situation, whereas another family in some other situation. For example, in certain cases, low power consumption may be the prime requirement, whereas some other cases speed. So, the different types of characteristics of digital ICs are propagation delay, fan-in, fan-out, power dissipation, speed power product, operating temperature, voltage and current parameters, noise margin, etc. So now we are discussing about operating speed. Speed of a logic gate depends upon the time that elapses between the application of a signal to an input terminal and the resulting change in logical state at the output terminal. It takes into consideration the transition time, that is, rise and fall duration of a pulse and propagation delay. So both of these times depend upon the loading and increase in load. The more inputs are attached to the output of a logic gate, the more load is to be handled by that output. High operating speed is usually the main requirement of the digital IC. So operating speed is one of the characteristics of the digital IC. Next characteristic is fan-in. So the fan-in of a logic gate is defined as the number of inputs that is coming from similar circuits that it can handle the system properly. Then next is fan-out. In general, a logic circuit is required to drive several logic inputs. The fan-out, that is also sometimes called the loading factor, is defined as the maximum number of standard logic inputs that an output can drive reliably. So the fan-out of a logic gate is the maximum number of standard loads that the output of the gate can drive without impairing its normal operation. For example, a logic gate that is specified to have a fan-out of 8 can drive 8 standard logic inputs. If this number exceeds the output logic level voltages, cannot be guaranteed. Next is power dissipation. So this is the amount of power dissipated in an IC. It is determined by the current IC that it draws from the DCC supply and equals DCC into ICC, where ICC is the average value of ICC0 and ICC1. This power is specified in milliwatts. Lower power dissipation is desirable feature for any IC. So power dissipation is the electrical energy used by logic circuit in a specified period of time. Power dissipation is the measure of power consumed and expressed in terms of milliwatts. So PV, that is power dissipation, is equal to DCC into ICC, that is average, divided by N. This is the formula for calculating power dissipation. So where DCC is the gate supply voltage, ICC average is the average current drawn from the supply by the entire IC, number of gates in the IC. So this is all about power dissipation. Next characteristic is power supply requirement. So every IC requires a certain amount of electrical power to operate. The power is supplied by one or more power supply voltage connected to the power pin on the chip. Usually, there is only one power supply terminal on the chip and it is marked as DCC for TPL or VDD for MOS devices. Obviously, low power consumption is desirable feature in any digital IC. Next, noise immunity. So noise immunity is defined as the stray electric and magnetic field can induce voltages on the connecting wires between logic circuits. So these unwanted spurious signals are known as noise and can sometimes lead to false triggering of logic levels in the circuit. The noise immunity of a logic circuit refers to the circuit's ability to tolerate noise voltages on its input. A quantitative measure of noise margin. Higher the noise margin, better the logic circuit. So, noise immunity is also known as noise margin. The noise margin is the maximum noise level voltage added to the input of a digital circuit that does not change the binary state of the output unnecessarily. Next, propagation delay. So, propagation delay is the length of time taken to reach its destination. In digital circuits, it is the time length where the input signal becoming stable and valid to change to the output signal is stable and valid to change, that is when input changes to 50% of its level output also retains its 50% of final output level. This delay is also called gate delay. They are measured in micro or nano or picoseconds. It can also be stated as the sum of all the delays in the longest path. The stable output is reached only when the longest path has settled. So, a pulse through a gate takes a certain amount of time to propagate from input to output. This interval of time is known as the propagation delay of a gate. So, another characteristic is voltage and current parameters. Voltage and current parameters means there are 8 types of voltage and current parameters. One is VIH, it is the minimum high input voltage. Then VOH, it is the minimum high output voltage. Then VIL, it is the maximum low input voltage, and VOL, it is the maximum output low output voltage. So this is the voltage parameters, and the current parameters are IIH, this is the high input voltage, IIL, this is the low input current, IOH, this is the high output current, and IOL, this is the low output current. So these are the voltage and current parameters. VIL Thank you.